jetty. One of these is the path. The graph is a straight line with a slope of -1/4. That's the key right there. Okay. If the mainland harbor is located at 2-1, so this is the start point, because we're going from the harbor to the jetty. So first we need to find that point, the starting point, 2-1. Here's 2-1 right there. Can't be this one. Here's 2-1. That one's okay. 2-1. It can't be this one. And then 2-1. So this one's okay. So it can be either B or C or D, because those hit at the correct starting point. My slope is -1/4. That means I'm going to go down 1 and then over 4 from my start point. So if I go down 1 and then over 4, that would take me there. Here, if I go down 1 and over 4, do you see how I'm off the line?
Yeah.
Bless you. So I can't go off the line. I have to stay on the line. So it can't be these. Does that make sense?
Yeah.
All right, so we have this inequality. Careen is adding hydrochloric acid to distilled water, blah, blah, blah. We have the graph, okay? And we want to find out which inequality best represents this graph. So what we have, this part here that's shaded, okay, every point in here is true. And every point down here would be false. So what we have to do is we can just pick a point, any old random point in here, and start plugging them in for x and y, and then we need to find the true statement. So I'm going to pick that point right there, because it's a small number, but I know for sure it's in the shading. And that point right there is 2, 4. Following me so far? When you have the inequalities, because I'm talking about greater or less than, I have a line, and then everything greater than that line or less than that line will be true. Okay? So everything in the shaded part up here is true. So I can take any of these points, and they should be true in the correct equation. So I picked this point because it's obviously, it can't be on the line. It has to be in the shading, and so it's obviously in the shading, but it's still down low, so I have small numbers to work with, so I don't have to multiply big numbers. That's why I picked that one. I could have picked this one over here, and that would be fine too. Or this one, or that one, or any of them in the yellow. So if I picked this point, because it's small, this is x and this is y, so I have 2 times y minus 3 times x has to be less than 0 if this equation is true. So I get 8 minus 6 is less than 0. That's false. So it can't be A. Okay, so then I try B, and I have 3 times y minus 2 times x is less than 0. And I get 12 minus 4 is less than 0. That's also false. So it can't be B. So far, is that making a little bit more sense? Okay. 2 times y minus 3 times x is less than 0. 8 minus 6 less than 0. False. Well, at this point, I've eliminated everything, so I know it has to be D, but I'm going to go ahead and work it so that you can see what it should look like. Oops. 3 times 4 minus 2 times 2. Sorry, that should have been greater than 0. 2 times 4 minus... I wrote that down wrong. Hold on. 2 times 4 minus 3 times 2 is greater than 0. I get 8 minus 6 is greater than 0. That's true. Sorry. I'm just going to double check this one. 3 times 4 minus 2 times 2. Hold on a second. Now, so those are both true. So from there, we need to figure out which one actually represents the line. Okay, so sometimes it doesn't, you don't have to do the second part. Sometimes you're only going to get one that's true, but in this case, we got both of them that are true. So what I'm going to do now is I'm going to take that 2y minus 3x, and I'm going to say equal to 0. And I'm going to put this into y equals mx plus b format. And I'm going to get 2y is equal to 3x, because I'm going to take that 3x and I move it over here. Divide by 2 and I get y is equal to 3 halves x. This needs to be the slope for this c to be true. So I would need to go up 3 and over 2. So starting at 0, if I go up 3, I go 1, 2, 3, and then over 2, 1, 2. I hit this point right here, which is not on the line. It's going up 2 over 3. But you see how that didn't work when I went up 3 and over 2? I'm not on the line. If I'm not on the line, it's not that point, so it has to be D. So I figured out which ones would work for the shading, and then I have to figure out which one of those two works for the line. So it has to be correct for both. Correct shading and correct line. And sometimes you don't have to check the line. Sometimes when you check the shading, it'll eliminate all but the correct one, but sometimes it doesn't work out that way. Does that make sense? So if you check the shading first, usually that's kind of easier because you just have to plug in the point.
I'm just confused because it goes by twos.
Right, but you still count 1, 2, 3 spaces. As you just count the number of spaces, even though each space counts as 2. This is not so much exactly 3. It's 3 spaces. Yeah.
The denominator is exponent.
The denominator, yeah, because the numerator is telling you how much to go up or down, and the denominator tells you right or left. So yeah, the numerator would be like a y, and the denominator would be like an x. Did that make a little bit more sense? Okay. The y-coordinate of the y-intercept of the line that passes through the points -4, -4, and 4, 8. Okay, there are 2 ways to do this. We could do this all algebraically, find the equation of the line to find the y. No, we don't have to do all of that. That's silly. I'm overthinking this. Do you guys remember what a y-intercept is? The y-intercept is the point where the graph crosses here, correct? Okay, the x-coordinate is always 0 on the y-intercept. Okay. What we have to do is we have to figure out if I have this line that's occurring, and I'm at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So I've got one point right there, and I've got one point at 1, 2, 3, 4, 1, 2, 3, 4 right there. I've got to figure out where I'm going to cross the y-axis. Now, I did not draw this perfectly, but I'm 4 over this way and 4 over this way. So exactly halfway between this side and this side, I'm going to cross the y-axis at 0, correct? And I'm up 8 and down 4. So if I'm 8 and -4, I've got 8, 7, 6, 5, 4, 3, 2, 1, 0. Just keep going. -1, -2, -3, -4. where we're evenly spaced on this side, okay. Hold on. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces on this side. So if we're evenly spaced on this, on either side of the y-axis, we should be evenly spaced up and down it too. Does that make sense? Halfway between 8 and -4, there's 12 spaces, so we need to be 6 spaces in between the two. Which actually put me right where I drew it, even though I didn't draw it well. Does that make sense? So the y-coordinate is going to be 2. So even if you don't draw it perfectly, if you're close, that line will hit pretty close to where it needs to be, and then you can just double check it by saying, well, how much space is between these? And if you're exactly halfway on the x's, you should be exactly halfway on the y's. Does that make sense? Kind of. You can just sketch it. If you have those 2 points, you can just sketch it and see where it hits the x-axis, or I'm sorry, the y-axis. Okay, well this one we're going to actually have to do what I just said, would you like to skip? So, uh-oh. Okay, so for 21, we have points 3, 2, and -9, 6. And so the first thing we're going to use is the slope formula. I'm going to show you the correct way to do this, and then the alternate way if you can't remember the correct way. Okay. Okay, that's the slope formula. So we can say this x1, y1, x2, y2. So I plug those in. I have 6 minus 2 over -9 minus 3. 6 minus 2 is 4. -9 minus 3 is -12. And that reduces to -1/3. So far, okay? So my slope is going to be -1/3. And I have to use this format, y equals mx plus b. And I have to plug in that slope, some x and some y, and solve for b. I had to take 1/3 of the x, so I want to look, both of these will divide by 3, so I could use either point. I want to use that one because it's smaller. Okay. So y and x. 3 goes into 3 one time. So I get 2 is equal to -1 plus b. So far, okay? Add 1 to both sides, and I get that b is 3. So my equation so far would be y is equal to -1/3 x plus 3. And you'll notice that this doesn't actually look like any of those. Remember this? Yeah. Awesome. So I have, none of these have a fraction in them, correct? So I'm going to clear the fraction. So to clear the fraction, I'm going to multiply by the denominator. And so I multiply every single thing by 3. And I get 3y is equal to -x plus 9. And x is over here. So I'm going to move this x over here. And it becomes positive. And I get x is plus 3y equals 9. That's the correct equation. That happens to be b. But let's say you don't remember how to do all that. you could still figure this out. Okay? In order to be the equation that passes through both of those points have to be true if you plug them in. So the alternate method you could use for this would be to plug in the points. So the first one is x minus 3y equals 9. So I would plug in the first x and the second x, or the second and the first y. So I'd get minus 3 times 2 equals 9, which tells me 3 minus 6 equals 9. That automatically is not true, right? So it can't be A. So then I'd go down to B and I'd plug in the first point and I'd get 3 plus 3 times 2 equals 9. That part's true. And then I have to try it for the second point to make sure it's true for both. And I'd have negative 9 plus 3 times 6 is equal to 9. That's negative 9 plus 18 equals 9. That's true. As long as it's true for both points, it's the correct answer. Does that make sense? So, correct algebraic way, I forgot how to do it. I can do it this way. This can be time consuming because you have to plug into all 4 points, but you know, if you can get there, it doesn't really matter how, right? So if we look at this, we want to go through 416 and we want to be perpendicular to that line. And that's important, perpendicular. So perpendicular, so here's M. Okay. If we were talking about parallel, we would be exactly the same. Perpendicular is opposite and upside down. So, right. So parallel slopes are the same. Perpendicular slopes are opposite and upside down. So what we have, okay, sorry, read that, okay. We want to be perpendicular to negative 2/3, that means our slope has to be positive 3/2. 2/3, negative 2/3, negative 3/2, positive 3/2. We didn't have to do any other work. That's the only one with the correct slope. Now, if, let's say, both of these had had the correct slope, they would have like a different y-intercept or something, then you would take the point and plug it in and make sure it was true, see which one it was true for. Does that make sense? If this was not a multiple choice question, you would have to plug it into the y equals mx plus b. So you would do that. This is 22. And I would plug in my y, my perpendicular slope, my x, and I would find b. Oops, plus b, not equals b. So you get negative 16 is equal to 6 plus b, and I would subtract 6 from both sides, and I would get negative 22 equals b. So I'd have y is equal to 3/2 x minus 22. So that's how you'd find it if you didn't have multiple choice. Okay, so first the shortcut. It's $6,700 to build 10 computers and $12,200 to build 20. And here's the equation. We want to find out which one of these is true. We're going to plug in 10 and see if we get 6,700, and then we're going to plug in 20 and see if we get 12,200. So first I'm going to plug in 10 into A. And so I'm going to get 5,500 minus 1,200. That is not 6,700. So it's not A. So if I try B, this does equal 6,700. So B works for the 10 computers, but we also need to try it for the 20 computers. So that's 20 plus 1,200. So that should be 1,100, I think. Sorry, 11,000. And that's 12,200, so that also works. So the answer is B. Okay. If this was not a multiple choice, you'd have to do the slope. And your points are 10, 6,700, and 20, 12,200. Those are your points, because x is 10 and 20. So you'd have to find your slope. And I would do 12,200 minus 6,700 over 20 minus 10. And I'd get 5,500 over 10, which is 550. And I would know that my slope, my slope was 550. And I would plug in 6,700 is equal to 5,550 times 10 plus B. And I get 6,700 is equal to 5,500 plus B. And I would get that B is equal to 1,200. And that's how I would get my equation. Y equals 550x plus 1,200. So if you had to do it this way because it wasn't multiple choice, that's what you'd have to do. You'd still use the slope and y equals mx plus b, which is anytime you're given 2 points, that's always the steps you have to take. Slope, and then y equals mx plus b. Did that make sense? All right, so for this one, do you see how the line doesn't exactly hit all of the dots? It's called a line of fit. And so when your data points don't give you a straight line, you draw the line that best follows within the data points to give you the straight line. So it's like an estimation line. And they're used to predict future outcomes. So this is the line they said best fit the data. This is kind of just sort of like an outlier because these are all really close. And they said based on the linear model, how much revenue should the company earn in the 5th quarter? Well, these are the quarters. Here's the 5th. So we want to extend the line out to see where it'll hit. Now, on a computerized test, this can be hard to do, but you could sort of maybe stick a piece of paper up to it and see where it hits that line. It's going to be about 48,000. Okay. Yes. Okay. So that's how you can do it based off the picture. Now, if they want an exact answer, we're going to have to use the algebra. And so what we're going to do is we're going to take this point here and this point here. That's a bad point. But it's the closest we have to one that's hitting on the exact. Well, this one hits pretty exact. Maybe we'll use these two. So between 4 and 3, we're going up 2 and over 1, so that's our slope. Do you see that? So our slope is 2 over 1, which is just 2. Okay, and then at this point we're at 330. So we can use this x and this y. And I can do 30 is equal to my slope times 3 plus b. So 30 is equal to 6 plus b. So 24 is equal to b. Because I subtracted 6 from both sides, so I should put that in there. So my equation is going to be y is equal to 2x plus 24. And this is 1,000. Or 1,000, because this was 1,000. Right, so this is actually 30,000, so that will be 24,000. And then I can plug in 5 for x. And I get 30 plus 24 is 54,000. So it's actually different than what we got when we drew the line. And that's kind of the problem with regression models. They're not accurate, they're not exact, and I don't know how exact they would want, since this is not a multiple choice.
How come it's 2 over there, but it's 6 over here?
Oh! Because I wrote down the wrong thing. Thank you for catching that. That's 10, so that's 34,000. Which is still not exactly what we got before. So you see, it's like, it's not going to be, that's the problem with the regression models. Like, because I didn't have exact points, this point was not exactly on 10. This point was not exactly on 40. So when I said up to over 1, it wasn't exactly right. But if I go up from here, I go 1, 2, 3, 4, and then over 2. So it's still kind of a 2 slope, but it's not exactly a 2 slope, so it's not going to give me an exactly the right answer.
For the answer, you would put, like in the box, you would put 34 or 50,000.
In thousands, so you put 34 or 48 if you drew the line. What I'm hoping is, because these are, all right, we got 25. Here's our y-intercept, so this is b, and that's 1. So we're going to check on these. Positive 1, positive 1, negative 1, negative 1. It's not negative 1, it's positive 1. So we can get rid of the negative ones. And then we're going to go from this point to our next solid point, which if you look, this is not quite hitting correctly. That doesn't. This one hits in the corner. So we're going to say, how many spaces do we go to go from here to here? I'm going to go up 1, 2, 3, 1, 2, 3, 4. So I go up 3 and then over 4. And that gives me my answer. Okay. Yeah.
Where did you get B equals?
B is where we hit the y-axis, and see how we're hitting the y-axis right at the number 1. That's where I got that. Determine the number of solutions based on the graph for the following systems of equations. What we're going to do is we're going to put both of these into y equals mx plus b. Okay? So the first one, I'm going to move this 2x over. So I have 5y is equal to negative 2x plus 7. Don't forget that if you move to one side, you change your sign. Divide by 5. And I get y is equal to negative 2/5 x plus 7/5. I'm not graphing this. My next equation was 10y is equal to negative 4x plus 14. And if I divide everything by 10, I get y is equal to 4 and 10 both divide by 2. So I get negative 2 over 5x. 14 and 10 both divide by 2, and I get 7/5. Do you see how these are exactly the same? Because they're the same, we have infinite solutions. Because the lines are going to lay right on top of each other like that. Okay. If you get the same slope and different b, so same m, different b, you have no solutions. And if you get different slopes, you get one solution. So same slope, same b gives you infinite solutions. Same slope, different b gives you no solutions, and then different slopes gives you one solution. You will never have two on these. The only way you end up with two solutions is if you get like a quadratic and a line intersecting. But anytime two lines intersect, they can only intersect at one place. And a system of equations like this is just two lines that are crossing each other somewhere. Okay? Alright, we're going to stop here for tonight.